Let's take a look at this example. Changes in airport procedures require considerable planning. Sure. Arrival rates of aircraft are important factors that must be taken into account. Suppose small aircraft arrive at a certain airport according to a Poisson process at the rate of 7 per hour. 7 per hour. Thus, the Poisson parameter for arrivals over a period of hours is 7t. Okay, so then t here would be the number of hours. So complete parts A through C. Part A, what is the probability that exactly 4 small aircraft arrive during a 1 hour period? Exactly 4 arrive during a 1 hour period. So we want the probability here that x is equal to 4. X is equal to 4. And let me just kind of note, remember, what is our probability distribution in general? The probability that x takes on exactly a value x arrivals would be e to the negative lambda t, so lambda t to the x over x factorial. So in this case, what's the probability that exactly 4 arrive? So then this is going to be equal to e to the negative lambda t. So what is this here? Lambda t for part A, this is a 1 hour period. It's a 1 hour period at 7 per hour. So that's going to be negative 7 times 7 to the x. So this is 7 to the 4th over 4 factorial. 7 to the 4th over 4 factorial. So we run that through a calculator, and that is approximately 0.0912 if I round that off to 4 decimal places. Part B, what is the probability that at least 4 arrive during a 1 hour period? So now this is at least 4. It's still a 1 hour period, so t here is still equal to 1, right? But it's at least 4, so now we're going to look at not just equal to 4, but at least 4. So greater than or equal to 4. Greater than or equal to 4. Okay, so in this case, since we're looking at a greater than problem, we want to look at the complement here. So we can do 1 minus the probability that x is less than or equal to 3. Probability that x is less than or equal to 3. And we can look, this is a cumulative probability question. We can look that up in the table, right? So we can look for our table. Mu would be 7 times 1. Mu is 7. So 7 is our expected number of arrivals per hour. And we're looking for at most 3. So we got to look in the table for 7 and 3. Let's see if we don't have that ready to go. All right, so mu is 7 and 3. I've got 0.0818. 0.0818 there. 0.0818. 0.0818. So what is 1 minus that? 1 minus 0.0818. You've got 0.9182. 0.9182. All right. And last part. Here we go. Part C. If a working day is defined as 8 hours, what is the probability there's at least 47 small aircraft arriving during a working day? At least 47 small aircraft arriving during a working day. If a working day is defined at 8 hours, so here we have t is going to be 8 hours. T is 8 hours. And we want the probability that there's at least 47. So 47 or more in a working day. So if t is 8, what is lambda t going to be here? Lambda t is, it's still 7 per hour, so it's 7 per hour for 8 hours. So this is 56 is the expected number. 56 is the expected number. So if we want the probability that x is greater than or equal to 47, again, we can consider the complement event here, 1 minus the probability that x is less than or equal to 46. But you might guess that we're going to have a problem here with a mu value as high as 56. Does our table go that far? The answer is no. Our table does not go that far. And nor does our R value either, right? We're looking for up to potentially 46 options. So what do we do in this case? What can we do in this case, right? Well, we have access to actually some calculator applets that we can work with here. So let's go ahead and dive into those real quick. So let me see here. I'm going to maybe need to switch formats real quick. So if we come across something like this that's not in the table, what we can do if we're working on our stuff online is we can go ahead and open up the StatCrunch button, which we probably have not used yet. StatCrunch is loading. Cool. So what we can do here then is I can click on Stat Calculators, and we're talking about Poisson distributions. All right, and certainly you could use this for questions that are in the table to check your answers. I wouldn't rely on this too heavily because I do want you to be able to learn how to use the tables appropriately when we have them. But in a problem like this, we do need to use the calculator. So let's update our mean to what was our mean in this question? 56, and we want to be less than or equal to 46. So our mean is 56, less than or equal to 46. Click compute, and that is 0.0993654. 0.0993654. 0.099. Just make sure I got that written down, and let me switch back here. 0.0993654. So we want 1 minus 0.099. Okay, there we go. And so that is 0.900. If I round this off to 4 places, 6. There we go. Okay. So just want to illustrate that some more practice and show you that you have access to some nice handy dandy calculators there in the StatCrunch applet. So again, that was opening StatCrunch, and then you click on Stat here, Calculators, and specifically Poisson is what we were looking at, but obviously you can see there's a lot of stuff on here. But the Poisson calculator is what we were looking at for that.